37 we're going to skip because you can see that we got a X there. That's not going to be on the test. Okay, so here we have it equaling 6. So we're going from 2 to 8, and it looks like it's just plain FT. So here we got some baggage here. So what we're going to do is we're going to isolate this f of t so that it'll equal this, that's 6, but let's see what we do with the other things, okay? So let's go ahead and separate first the 2, t dt plus, there. Okay, so what we did is we treated like this as 2 pieces. There's the plus 3, so he is his own integral now. And then he is his own integral, but we took the 2 out because it's a constant. That's one of our properties, okay? So this means this guy right here, we know that he's 6, okay? So 2 times 6, and then we just have to figure out what this guy is. Now, because he's a constant, if you remember, we've got a little formula there. This is the constant times b minus a. If you remember, it looked like this, okay? And it's a rectangle. So you could find the area of this pretty quickly if you drew a graph. It's just a flat line. You're going from 8 and you're going from 2. So you got a distance of 6 times 3. That's 18. So if in doubt you forgot the formula, you can actually just kind of see that that is it's a rectangle when you take the derivative of this guy. So we've got 12 plus 18 is going to be 30. Okay, let's zoom out here. Okay, so it looks like this is a calculator thing, so we're going to actually set this up in the calculator, but then also just frame this correct. So we need to find the average depth of water from noon to 3. Okay, so the average. Here is the function, and so it gives us, okay, this is great. Okay, it's the average. This should be the depth of the water. That's exactly right. We are going from noon to 3, so don't put noon as 12. Put it as 0, I think. Let's see. Oh, it's starting at midnight. Oh, okay, whoa. So we're starting at midnight. So we will actually put noon as 12, but we're not going to put 3 p.m. as 3. Yes, you know it's going to be 15. It's the 15th hour from midnight. I wish we would just use military time. I don't know why. Like, that just makes so much sense if you would just say it's 15, you know, or 1500 hours. Like, why? Why not? Okay, so we can just write this out here. Okay. All right, but what we do have to do is do the average, so don't forget this. Okay. All right, so it looks like whatever this is, whatever we get here, we're going to divide by 3. So let's go ahead and enter this in very carefully. Math, go down to 9. And we're going to go from 12 to 15. And we're going to have negative cosine. I am in degrees, so let's change that. Radians. Okay, and then we're going to go back here. Insert. And we're going to have pi over 15. T or x. And plus 2 x. All right. There we go. And then divide by 3. So the average height is going to be 2.99 feet. 2.935 feet, which is perfect. All right, now that definitely gives us a way here, because like that makes sense. We're going to go either above 2 or below 2. The max value here is going to be -1. So really, oh, but they changed the period. So yeah, so that makes sense. These guys actually don't make sense. Yeah, this would be 3 would be the highest. You probably have to type it in wrong. Anyways, that is the answer for this guy. Medicine is dripping from a container through the IV tube of a patient at a rate of this. Okay, that's a very complicated function there, per minute. So that is a velocity. Okay, it's a rate where T is measured in minutes. Of the IV contains 425 milliliters of medicine initially. How many milliliters of medicine remain in the container at the end of 1 hour? Okay, so we have the rate, and if we take the integral of the rate, we can find out how much has been lost. Okay, so you start off with 425, but if you have the rate by taking the integral per minute, if you're taking milliliters per minute, if you took the integral of this, you will end up with milliliters. So these milliliters minus those milliliters will be how much is actually left. Okay, so if it said how many milliliters of medicine is lost or outside, well then yeah, you would not subtract it. Okay, but you really have this right here, and you're only going from 1 hour. So you're going to take luckily we're using a calculator here. I think the antiderivative here would have been quite beastly. Okay, but this tells us, because it's a rate function, we're going to get the actual amount of milliliters in that first hour. Okay, so let's do that. We're going to go ahead and go to math, of course. Going to go 9. We're going to go from 0 to 1. We're going to type all that in. We got the ln of parentheses 1 plus x, close parentheses, plus cosine. Who figured this out? It's pretty wild that somebody took the time to figure out that this function looked like this. Okay, then there's the big parentheses there, and yeah, we're going from x. Okay, and that looks like 1.149. So take 425 minus that much. Got 423.85. So that's beautiful. That is how much, not a lot, has left the system. And that makes sense. It's dripping from a container. So that is it's just dripping. So after 1 hour, not much has actually, there's still a lot there. Okay, but that is the function. So some kind of biologist must have figured out that, or some engineer figured out that would be the drip rate. So that's cool. All right, what else? What else do we got? This, we're not doing this guy, so we're gonna skip all that, and that's gonna be the heart of the test. Honestly, let's not even waste each other's time with the true and false, just because we're gonna keep the test so that you can do it in 1 hour, and most of it will be kind of antiderivatives, basically the stuff that I made the videos on. That's what it's going to be on. So do keep in mind that this counting squares thing is good intuitively, but I'm not going to put one of those on the test. What's more important that you know how to do the trapezoid, and if you can do the trapezoid, you can do the left and the right for sure. Okay, so study those if you've got it. It's not on the study guide, but everything else looks pretty solid, everybody. Good luck, and I'll post these ASAP.